I am super jazzed to introduce the next three panelists. I feel that, over time, we've almost become friends because we worked through some really gnarly problems together in scale or, partition density or throughput or complexity of governance. And so it's going to be all about AR governance. And so if you're struggling with it, if you're just an engineer, just like, how do I monitor the systems? It feels like, I used to say this a lot with previous generation systems. There was like a system of whack-a-mole. That's the next level here. And so would love to welcome to the stage Kannan, who is the Chief Architect and VP of Engineering at LiveRamp. Welcome, Kannan. Super excited to have you. Get ready for a spicy conversation. Welcome onto the screen. Thanks for joining us.
Thank you, Alex.
I want to follow up by introducing Shil. So Shil is the VP Product Engineering and Data Science at Arctic Wolf. For all of you that you don't know Arctic Wolf, you're missing out. One of the top security companies in the world. So welcome on screen, Shil. And then,
Alex.
Yes, thank you for joining us. It's gonna be fun. And then last, I would love to introduce Arya. And so Arya has been a fun partner for me to work with on some of the gnarliest scales. So if you don't know what ShareChat is the largest social media company in India, and he's a distinguished engineer at ShareChat. He's just gonna tell us the truths. And so welcome on stage, Arya. Thanks for joining us. Okay, so with that, let's see. I want to introduce, I guess let's kick us off here. And so, Kannan, you and I have worked for so long together. So for the audience, Kannan was the first user of the new version of the BYOC, and we delivered the first version of BYOC, and then we kind of tweaked it together here with LiveRamp. And so maybe we'd love to just give like a 30-second intro on LiveRamp, and then follow it up by, contrary to popular belief, AdTech is intensely focused on confidentiality and privacy. So maybe share a little bit more, like what is LiveRamp and why are you so intensely focused on confidentiality and privacy?
So yeah, I think let me start with a small introduction about LiveRamp. LiveRamp is a global leader in data collaboration, basically. We provide trusted infrastructure that enables brands, publishers, and partners to connect and innovate with data, of course, safely and securely and at scale. Because ad tech data is huge, right? So providing an environment to do that in a safe and secure way is the biggest challenge. That's what LiveRamp has been doing for a while. And basically they let their customer touchpoint data and unify the data and activate across channels and measure the results to the precision. All this ensuring privacy and compliance, right? We've been doing that for a while. Even our product is called Safe Haven and Clean Room for the reason, because that's how we've been doing it. And so for us, right, the data is because it's a customer touchpoint data for our customers, right? So those data, when we interact or when they share between their partners, between their things, it has to be secured, and they decide what to share and how to share. That precision of sharing and security on that micro level control is key for us. Yeah, that's what we have been doing so far.
Yeah, thank you. That was fun. I know it's actually, when you talk about the precision of data sharing, there's a ton of systems that are involved of who's having the right access to the right things. And so it's going to get more spicy with agents. We'll come back to you, Kannan, in just a second. Yep. Shil, I introduced Arctic Wolf as a top security company, but that could mean anything. It's like, security is such an expansive thing. So would love for you to give the audience just a couple of minutes of context of, what is Arctic Wolf, and then we'll start digging into the agents and, how you're thinking about the world and governance. But maybe let's kick us off by telling us a little bit more about Arctic Wolf.
Yeah, sure. So, Arctic Wolf is focused on managed security services, right? Our customers are basically, anybody who doesn't have a SOC, and effectively we're in the business of providing a managed security services, either through endpoint services, connecting with all of the application services that you have, ingest all your telemetry and run it against in our infrastructure provided through an autonomous way of delivering security. So really, in a nutshell, I think Arctic Wolf has one of the largest SOC, if you will, outside of the government, and manage detection remediation services through that. I think that's the shortest explanation.
Thank you. It's always fun, as a builder, because I grew up as an engineer. Usually, when my team releases a feature, my first reaction is like, how do we break it? And so it's always fun to partner with people because they break us. And so either it's like Kannan, I remember, was pushing the permissions of BYC, and Arctic Wolf was like a bunch of scale. And so let's dig in, because this is a juicy topic. And so when I talk to CIOs, there was this challenge of basically governance for CIOs is a challenge of access controls and observability. Those are kind of like core things. So we'll dig into that. I see Arya just joined us. Welcome back on the stage, Arya.
Thanks,
super
Alex.
excited to have you. No worries. I introduced you as being a distinguished engineer running one of the largest social media companies. Tell us a little bit more about ShareChat, because we're about to get into the meat and potatoes of the discussion. So maybe 1 second, introduce yourself, what you do, and then what's like the key takeaway for people as what is ShareChat? Because I want to balance, basically B2B, security, and basically social media. There's totally 3 different demands on AI governance. So maybe kick it over to you. Tell us a little bit more about what is ShareChat and what do you do there?
So ShareChat is a social media company. It's a digital native platform for people to discover content and consume content in the language that they interact with their friends, with people that they know, right? So we are based out of India, and we are there in like 16 different languages. We have a healthy user base of about 225 million monthly active users. So people come to our platform to consume content, discover people, discover trending and most entertaining content that they can consume. So think of it like TikTok for India and being delivered by Indians, right? So our platform runs on huge amounts of data, both for content that is getting generated and then people who are like kind of engaging with the content. So we use a lot of AI based systems to kind of recommend content to the users and entertain them, right? So that's in a nutshell like what we do. I work as the distinguished engineer here, shepherding the company into various different fantastic technologies like Redpanda and others. We use a lot of them, cutting edge technologies to kind of deliver solutions for the business that we run, right? So we're a B2C company. Users can come to our platform, interact with what we are kind of recommending them, and then consuming them, right? So that's
Thank you. Entertain, that's the game. And so hopefully this will be entertaining for people. Shil, over to you. So as we move towards this agentic security, see, it feels to me, I guess here's my thesis. AI feels like it's a superset of security, infrastructure and data. It's kind of all encompassing. So as we move towards this agentic architectures in cybersecurity, what mechanisms can we use to distill, SOC analysis playbooks into stack-specific agents without losing this nuance, as you mentioned, of, this like basically taste, this high, there are high stakes scenarios. And so tell us more about, the mechanisms that we use to distill SOC analysis playbooks.
Yeah. Thanks, Alex. First off, I'd like to say, look, cybersecurity industry were the first adopters of ML. I'm talking about, 10 years ago when AI and machine learning in general context was not as prevalent. Because at scale, the only way that you can prevent, detect, and remediate threats is through machine learning, like as you see through systems. And it's not just about anomaly detection. It's about detecting specific threats with specificity, because, you're going to take an action either on the endpoint or services in the cloud that is going to be detrimental to the service if it's incorrectly done, right? So I think with that, we're at a point where the SOC, security operation analysts, their expertise can definitely be distilled into task specific agents, whether it's for lateral movement detection, malicious script being executed, or just general malware in any of the kill chain that's getting executed. And we're seeing more and more of this, like ransomware, like you just have to type in the every day there is one or the other event. So in relation to governance, like what it means is more automation, of course, is going to happen, right? And how do we preserve the human judgment, especially when we talk about distilling and escalation path? So the human in the loop is something that you hear quite often. And internally in Arctic Wolf, like we've tackled this problem in two ways, right? We have a very large amount of data. I mean, we use Redpanda, and the volume we're talking about, we're processing about a trillion events per day type scenario, right? So, taking all of this years of experience that humans have triaged this data, and with this volume of data, like we're able to sort of train very specific models that take metadata, do fusion, and does cross distillation from classical machine learning models. And this allows us to keep the boundaries in which the models sort of operate, or these agents that operate, and able to learn not just what to detect, but how an analyst would typically respond. So we're able to embed these escalation logic based on confidence thresholds so that agents can defer any uncertainty to a human, but when it's highly certain, it can take those actions. So our goal isn't to replace these analysts, rather it's to extend their reach, codify their intuitions, and ensure that every agent decision reflects what the enterprise would have intended to do.
Totally. It's like, imagine blocking the Redpanda traffic or something like that. It's like catastrophic, right? Like you literally take down the entire data system.
That's the thing, right? Somebody gets an email, and we kill that particular application, Outlook shuts down. I mean, just imagine that. So the specificity and accuracy has to be very high. In the business of cybersecurity.
I love the idea of building this confidence level, and it's like, look, after some point, I guess one of the fun parts of partnering with you on this is like, no, we're like pretty good at this. Maybe the world doesn't know how, I guess the colloquial phrase is how the sausage is made, but it's fun, I think, because the 2,000 people that are dialing in right now, most of them are sort of builders, makers, doers of this system. So it's kind of fun for them because they get to learn from how you're thinking about the world into that. Kannan, you have been, we talk about this data collaboration workload. And so as it relates to AI governance, as it relates to like having the right access, I think you mentioned to me offline, you're like, yes, on the left join, but not on the right line. So tell us more how you're thinking about governance in AI. Like access to data is that's basically the bread and butter, as far as I understand LiveRamp, is like, the ability to shape these data products in a way that deliver more value for end users. I'm probably doing a bad job at this, but tell us more about this data collaboration and AI governance here.
Yeah, thank you, Alex. Yeah, actually, right. As data collaboration, as our core product is about giving a secure space for our customers to come and collaborate, right? So that means, that all this governance and security, as we covered that, right? So we've been in this space for a while. So our basic system is built for it. So we could able to protect the data and govern it, and go by basically setting the right permissioning and right granular permissioning to get the data access for that specific use case or for that specific run. Now, how do we transform that into in the AI world, right? In the new guardrails, right? So basically, when we started thinking about AI, the first layer of saying, hey, how do my customer interact with my applications? Yeah, using an LLM or using a natural language way of interacting with our applications. That was an easy thing, right? And then later we started thinking about, hey, how do we give them metadata access so that the AI applications can interact with our applications with minimal metadata access. Right? Until that part, we were all good and comfortable and doing it, right? But when it comes to giving access to data, and when the data, and then let the AIs act on based on the data, that is when all the complexity started, right? So how do we control it? How do we granularly control that so that we confidently know that's what that can be done, and also we have to sell it to our customers because we have historically done that amazingly, like our products like safe haven and clean room. We have done it already, right, with data. So we have to do that now. So that is where our investment is right now on the guardrail, right? So to precisely build a guardrail which can precisely control how we share the data. When it comes to that, right? So one of the biggest challenge we had is currently our data is around 96 petabytes. Okay, the data we're dealing with, right? So with the 96 petabyte, and one of the things I want to share is last week our new migrated system, which we've been working for 4 years, reached a 360K virtual CPU at one point, right?
Wow.
That's the yeah, that's the magnitude of the data, right? So with that magnitude of data, how do we make it available? So one of the things we did is, okay, we're dealing with segment data, so we bitmapped it, and now we created from the bitmap, we created a vector and a sparse vector, so that we can make it available more controlling. With that, we're creating a metadata layer with the bitmap, so that we can have precise control on the data part of it. Right, one is compressed, and we have a precise control over it. And then we are developing a guardrail rule engine kind of slug, so that we can set the guardrails. Because here, when they share, and as I was mentioning to you, they want to share only 2 columns of the table. All right. And on that 2 columns also, they want to look up on it. They don't want to join against another data. So there are like so many minute rules we have to follow. Right. So that's where, the whole journey with Redpanda is playing a bigger role. We were the first one in the BOAC. We were the first one in the shadow indexing. And we were the first one to adopt and use the connectors a lot. Now with the agentic data plane, I'm so excited to work with you on that, building that guardrail, right? And so we are in that process now.
Right, because I think for those of us that grew up integrating APIs, I say this about my HR system. And so it's like, okay, I'm going to use HR for like onboarding and offboarding of people, right? So like I have to hire a new engineer, blah, blah, blah. What access do you have? I have to hire a new executive, different access controls, regular standard things. Everyone does this, right? That problem is not new. What is different in the pre-agents to post-agents is that most systems, because they were built before agents, it's sort of this like root token access. And it's like, okay, here's an API key. I was like, no. Hold on a second. I don't want root access to all these agents. I want like Alex to see, let's say whatever, this equity position or the salary that would be different from my head of revenue or from like my head of product or from my head of security or my head of engineering, right? And so that's the nuanced part. And so you're taking it to the next level, which is like, okay, imagine that in a clean room concept when what we sell to customers is 2 columns of a database. Or what we sell to customers is the join of this like, whatever, this like sparse columns. And so talk about scale at 360,000 virtual CPUs is always fun. I want to come back because I want to learn a little bit more about a scale. And so I want to tee up the next question for you, Kannan, which is like building confidence, building trust. But let me switch here over to Arya for just a second. Arya, social media is gnarly. Both in a scale too, and just kind of like the usage patterns are so viral, and so like you're kind of steady state is like you're like, okay, I wasn't ready for 100x, but you are. But my point is that mentally, I think 100x feels like such a crazy scale. How are you dealing with access controls of this like task-based authentication for agents? Tell us more like, what is your journey with AI? How are you dealing with access? How are you, maybe share with the world like tactical and useful tips for dealing with the chaos that agents bring.
Right. Thanks. So yeah, Alex, you're very right that, social media comes with very viral scale, right? So for example, we have these events, right, where, for example, when we did the first moon launch, right, out of India. So we're not kind of prepared for the scale that we suddenly got in, right? And our system started firing in as soon as, India launched that satellite, and then, people were just coming to celebrate on a platform, right? And as with most social media platforms, right? So that's the kind of viral scale that suddenly we get into. Now, behind this, right, like to support that scale, you need like a bunch of systems that can scale well. And then obviously at that scale, there are issues that come up, right? And then like systems need to react, right? So the kind of agents that we have set up on a system is basically, so one is around data itself. Like, we use a lot of recommendation systems to trying to figure out, hey, which content is the right content for the user who's trying to kind of come onto a platform, right? So that means that a bunch of systems that sits in our control plane try to direct the data to the right systems on which these models and these training sets can happen, but then there needs to be like a lot of governance around data validation, figuring out correctness of data and stuff, right? And then the second part is obviously like, when things starts falling off, right, like you need to figure out like, hey, what's breaking and what's working, right? So we have these bunch of like, internal agents. Being a B2C company, like we have not yet, like we're not kind of developing agents that works that works for like a business to business use case, but more like, these are like internal agents that tries to govern our system, like overlook and oversight our systems and try to figure out, hey, what's working and what's not working, right? Now obviously that means that some of these systems will have like a lot of access to lot of internal data sets, right? And that is where the governance control starts coming in, right? Like, hey, we have these real-time streams of user engagements, features, and feature logs, typical recommendation systems, like when you set up models, you kind of train on features that are generated, and then again map that to engagements, right? So the are basically the internal systems that we have to govern like how these AI systems are performing needs are heavily governed and guardrailed, right? And therefore they need like right set of ACLs and controls to ensure that they don't have inordinate access. And second is that they are able to not have very long lived access to that data, right? So but then if you think about it, right, like no matter where the systems evolve to, the software principles don't really change, right? So it in our experience at least, it kind of went back to the basic authentication and authorization controls that we need to put on our systems, which basically meant that you need to have like a central authorization server and central kind of authentication. Authorization is basically figuring out who like what kind of I mean, what kind of resource a particular agent has access to, right? And therefore what agent X can do on data Y, and at what levels, right? And then obviously authentication itself, right? And we didn't want like long lived authentication taken. So like our implementation was more like, hey, set up an OAuth kind of server with short-lived tokens. So and then with fine-grained access control with via systems like I mean, there are a bunch of different implementations that are possible through open policy agents and whatnot, right? So these are basically how we're trying to deal with it. But I think the basic software principles don't really change, but and they still are kind of valid even in the new world.
Totally, I agree. This JOT-based token, one of the premises actually for starting this agentic data plane here. And Shil, I want to dig into like you're reacting in real time to this like super highly impactful things. We talk about taking out by way of example, if you make the right choice. So you're acting in real time at like relatively large scale. I know it's because we've been partnering for a while. How do you ensure that the decision of some of these things are auditable? Like, okay, what happens if something goes wrong? How do you make sure that all of this agent decision or this autonomy remains explainable, auditable, and aligned with like the policies that you want to follow, right? So to say if you're like, look, business, I promise I'm going to do 1, 2, 3. And how do you make sure that in fact the agents do follow 1, 2, 3? How do you like follow this explainability principle to the infrastructure level?
Right.
Yeah. So Alex, it again comes down to this governance thing, right? In terms of how do you make this, like, what we've learned is, I'm going to try and answer this in two ways. Like, first, if you think about governance, like what exactly is governance? Like, in my view, it's basically a control system for autonomy, right? Human governance manages choices, and agentic or AI governance manages autonomy itself, right? And in practical terms, it's pretty much what most people do, or most industry in terms of software. I think my fellow panelists already explained, so I'm not going to go and explain that. Like, for example, in our case, agents ingest structured log events. We use declarative Redpanda pipelines. We act based on the streaming context. We enforce governance through schema-bounded constraints, embedded policy checks, agent level telemetry, and all of these things. I mean, pretty standard things. But I think in enabling traceability and in enabling the reasoning, I think the fear factor is agents can operate on things that we don't understand and cannot be explained. So I think we have to look at it from an error percentage. If you take a human and you look at the total number of decisions that human has made and what is that error rate, and if you can establish that in terms of a probability distribution of what the error rate is for these machines or agents, whatever we're going to call it, and if that outperforms the human decision and choice grouping, then you have a system that is completely governed, and you can explain this now, or rather completely audit their actions. Now, in terms of explaining, I think this is where the industry is struggling with unbounded conditions. And what we've been looking at is basically this notion of probabilistic bounding. So it's difficult to get into the details of it, but at a very high level, in my view, this is probably the modern approach or the right approach for agentic governance. And the idea here is that in a complex system where safety and decisions have hard limits, shaping the landscape of possibility itself is important. What we think of this is, if you can embed constraints directly into the agent's probability distribution actions, in other words, if you can ensure that an unsafe or unbounded behavior are statistically negligible out of all of the possible actions that the agents can take, and basically taking this approach, this I think will help us transform governance being restrictive or reactive into proactive and built into the design, as opposed to trying to protect it from the guardrail perspective, build it right into the system where out of all of the decisions the agents can take and bounded by the probabilistic outcomes. And thus it'll help us, I think, enforce autonomy and calibrate intelligence, basically. If you can know all of the possible outcomes that the agents can do and categorize them based on their probabilistic likelihood and whether it's safe or unsafe, and then bound those decisions by that, then you have a perfectly explainable governing system that you can now test it against the human choices that you've done, because that takes the fear away. If the human makes 2% mistakes out of 10, 20 decisions and the agent makes 2, I think we somehow feel that agents, we have to compare it against a baseline, and the baseline here is the human.
Exactly. I mean, I think the uncomfortable truth, we're just going to come out and say it, right? So the uncomfortable truth is look, some of these systems are better than humans. Kind of why we have a business, I know Arctic Wolf does more, but really you could just tweak this algorithm to be better. And so the shift is okay, well, the human shifts into this strategic thinker here, and it's not, but you can tweak the systems to be better at a whole class of problems. Maybe not all problems, but there's a large class of problems, especially when you talk about just look, the data, the volume, the scale, it doesn't make sense for a human to watch, right? Okay, so we've moved on past that, and I think we're there. And yet, still for the super highly impactful decisions, you can still, like you mentioned, with probabilistic bounding, just be better. And it's just look, data is data. I don't know what to tell you.
Basically constrain that based on that. And you know what, for us, being able to automate tier 1 SOC, I mean, that's where we are. At tier 2, tier 3, yeah, sure. A human decision is required because those are more complex, requires much more in-depth understanding. But at least the tier 1 SOC, I think, is definitely automatable. And that's where we are.
Arya, the audience has a question for you, which says, Rene, welcome back, Rene. Great to see you here. So he says, Arya, you mentioned scaling. Was the issue more about the huge amount of data and also spike and scaling up and down? And how was Redpanda superior to alternatives? So answer that in combination with explainability of AI. If you can do that in one answer.
So I think first about the scaling, right? So obviously the issue is around huge amount of data and the traffic that we see on the platform, right? And traffic therefore means that huge amount of data that we start producing on our Redpanda queues, right? And I think the great capability that on the superior bit is that, hey, the system's kind of auto scale, right? So for example, you want to kind of scale up for an event, right? The architecture that Redpanda provides is provide you to kind of auto scale on the event volume itself, right? So the two aspects. One is hey, can it auto scale on a particular immediately, right? So probably no. But then if it is if you're able to kind of have enough I would say scaling constructs built in, as an example, right? Like how can you scale from like think about the Redpanda queues, the topics itself, right? So scalability can be done on, say, topics, depends upon the consumption lag. So there are multiple factors on which the scalability, auto scalability can be built in, and Redpanda has like a lot of built-in features that allows you to do that, right? Against some of the alternatives. So yes, I think our problem was around huge data spikes and us able to kind of maintain the velocity of the data pipelines even with that scale, right? So that on the explainability bit, I think uh, the way we kind of try to reason about data, and I'll give you an example, right? So for example, we have the lot of data content that is getting created on our platform, right? So any social media app, a user uploads a post and there are like tags associated with it, right? And for example, one of our use cases that we kind of developed and was that, hey, whether a tag is kind of relevant to that particular post or not, and is that tag kind of inappropriate or NSFW, which is like not safe for women and stuff, right? So this kind of the amount of posts which is runs into millions of posts getting uploaded on a platform. Previously we used to put humans in the loop to kind of validate them, right? And obviously that was not scalable. But with AI systems, LLMs coming in, we kind of ran an experiment to kind of figure out whether we could automate this entire process, right? But then as you guys were saying, right, like, hey, the baseline is still a human evaluation, and then how do we know whether the newly generated system, automated system, is better or not, right? So we kind of develop this human in the loop kind of system, which, and we did this in two phases. One was that, hey, we kind of, against the same content, we ran like online experiments to show to different users different kind of tags, right? Like whether to the same person an irrelevant tag was shown and the relevant tag was shown, like basically one which was human validated and one which was machine validated, right? And we could actually see improvements in our metrics, right? So that gave us an instant feedback through aggregated user metrics on the engagement, that, hey, whether the automated system is working well or not, right? And the second was obviously running a sample of the same the machine the AI generated output against human evaluators, and then being able to validate whether the machine validated output is relevant or not, right? So but again, like, the explainability is built through a couple of things. One, humans being part of the system. Second, being able to, I think we don't like to focus too much on the traceability of the execution steps itself, right? But then if you are able to kind of build a system where agents are able to, or basically they're able to log the tools that they're calling, right? Like the models that they're executing, or the data enrichments, aggregations, joins that are happening, and the decisions that are being made. Once you build this kind of traceability, right, and that basically a lot of it comes through the governance, the data plane, agentic data plane that Redpanda is kind of building in, then a lot of these decisions is then explainable, right? And
Exactly.
that is where like, I think I mean, trace is the best way to kind of explain something, right? We have used that in the past to explain how our software execution happens. There is no reason why that shouldn't, the same principle should not get applied for even for the agentic software execution.
Totally. Well, what's nice about having the social media is you can run experiments like, user one, is this a cat? User two, is this a cat? I know we're using it in the age of agents, but like, it's kind of nice. Kannan, we'll close over the session with you, and we have like so many questions. So maybe we'll follow up with all of you separately, because there's just questions coming in. They all want to hear more from all of you. Kannan, help us close this session, which tell us is, how do you deal with AI explainability for LiveRamp?
So yeah, that is the biggest challenge, I think, right? So for us, right, one other thing is the privacy and compliance is in our DNA. So we've been doing that for decades, right? That part is easy, but with the explaining how it is NX with the AI, right? That is the part. It was harder part, and that is what taking a lot of time and things actually. But the basic understanding is that understanding for AI is a different and disorder. And the other biggest challenge, I think, hope you guys are also facing it, is that how do we do it economically, right? So the cost factor is huge right? When it comes to such a huge data set, moving from aggregate with, and then now we are dealing with signals and more even data, it's NX the data. With the NX the data, the complexity increases. And the compliance also gets even more complicated with AI and more access to that, right? So that is the complexity part. That is where the biggest challenge is. And it has to be, dealt with it in a way, there's no short answers to it. There's no silver bullet to it. Actually, we have to deal with it, and it's a bigger problem to deal as well.
Well, distributed log, what's nice is you just continue to append these events. And then, as you saw, I'm not sure if any of you dialed in this morning, talent demo, an ability to query the stream. Team, thank you so much for joining me live. So many more questions coming. I wish I had an hour to kind of brainstorm, because this is like what a fabulous panel. So thank you all so much for joining us. Thank you for the audience.